So good morning, everybody. I'm Patricia Pavier. I'm the director of the Office of System Integration and Analysis. And today I'm going to present you FC1, FC2. We will have also FC3 and FC5. My colleague, Dr. Stephen Kong, will introduce you to electrochemistry and also uranium in seawater. I'm going to focus on the material recovery and wasteform. So I think since some of you do not know so much about NE5 and we have had some modification and new people coming in, I think this is very important for you to understand who is managing the fuel cycle technologies and then the different offices. So we had Monica Regalbuto, who was our Deputy Assistant Secretary for the Fuel Cycle Technologies. She moved to EM, so now this is John Ersek. The Associate Deputy Assistant Secretary is Andy Griffith, and we have 4 offices. So I am leading the effort of NE51. Inside of that, we have electrochemistry, like I mentioned, Dr. Stephen Kong. The material recovery, our DOE manager is Dr. Jim Brazy. Wasteform are done with Kim Gray, and uranium from seawater are managed by Stephen Kong. Then after 3 presentations, I will come back and I will present the fuel cycle options analysis, FC5. The manager is Ken Keller. We have also Andrew Griffith for NE52, Bill Boyle for NE53, and Dave Anderson for NE54. So I want you to understand a little bit what is the Office of Fuel Cycle Technologies. We go from cradle to grave. Uranium resources, uranium from seawater, and then we emphasize on fuel fabrication, so this is Andy Griffith's office. Then recycling, this is my office. So material recovery. Before we used to call that separations, we have changed the name, material recovery and advanced wasteform. And of course, we have also disposal with also all the wasteform. Okay, the campaign objective. So we are focusing on the material recovery and wasteform. We are trying to develop a sustainable fuel cycle. What is important for us is to create this synergy between the academia and the national labs. We have a decline in radiochemists, nuclear engineers, and I would like to emphasize the people who are going to write a proposal to engage their students and to engage also the national labs. So the fuel cycle recycling technology gaps. We have here on this slide the present to the future. We have some gaps. We are focusing a lot on R&D, fundamental understanding, of course, on different processes, the minor actinides, separation from trivalent minor actinides from trivalent lanthanides, of gas management. You know, when you dissolve the fuel, we're going to have some release of radionuclides, iodine 129, krypton 85, tritium. So we have to manage perfectly this off-gas. Fast reactor fuel separation, dealing with electrochemistry, wasteform and processes. And of course, we have to keep in mind, this is not Office of Science. This is NE5. We're focusing on applied. So we want something in the long end that will give us a product that could be applied. So the different major areas, we have the advanced aqueous. We develop, we demonstrate new technologies. The minor actinide Sigma team is focusing on groundbreaking research. Really, it's R&D trying to find new way to separate actinide from lanthanides, for example. The off-gas Sigma team is focusing on iodine 129, tritium, and also krypton 85. Fundamental science is thermodynamics, kinetics, radiation chemistry, all the radiolysis byproduct. Separation process alternative, we are trying to find processes that are cost-effective, that are alternate to the actual process that is used industrially. of course, advanced waveform. If we separate, for example, iodine 129, what can we do with that? So we have to create new advanced waveform that goes with the used fuel disposition campaign and their generic disposal. Finally, uranium extraction from seawater, like I said, will be presented by Stephen Kong. We're trying to find new ligands, increase the absorption of uranium on this ligand, and the electrochemistry, which deal with the fast reactor fuel. So the needs, what do we need? You're going to tell me more or less the same. Because we are on the R&D mode and we want to understand the fundamental chemistry of separation, we have some needs. I will encourage you to focus, really to focus on the processes that we are doing in the campaign. The campaign is led by Dr. Terry Todd at Idaho National Laboratory. We're focusing on ALSEP, on advanced toll speak. You will see here SANEX and GANEX. These are processes done in Europe. We are trying now to stop all research focusing on the separation of americium from curium, more concentrating either on an homogeneous recycling, which means that we will have one step extraction, uranium, plutonium, neptunium, americium, and curium, or an heterogeneous recycling where we will have a two-step process. For example, uranium, plutonium, neptunium, followed by trivalent actinide, trivalent lanthanide. So we need knowledge on the speciation of actinides, on their behavior, on the structure, all of that is part in recycling technology. The second call for the material recovery is for the Sigma team focusing on gas. So we have a need for trying to capture efficiently iodine 129, krypton 85, and tritium. We would like to have very specific extraction, not to mix iodine 129 with tritium, for example. Why? Because of their half-life time. One is 1 billion years, the other one is only 12 years. So we would like also you to incorporate some modeling. You do research, it's good, but in the research, put some modeling. That's a plus. For the waveform, we have this year a call on the ceramic waveform. We would like to have an understanding of the phase transition leading from the melt to multi-phase. This is very important for us to have all this data. I encourage you strongly to team up with national labs. The main national lab that is working on glass ceramic waveform, glass waveform, it's PNNL, and the lead is John Vienna. So do not hesitate to go contact, outreach the national labs. That's the key to get a good proposal. The second call for the waveform, it's on the zirconium recycling. So it's a process that is developed at Oak Ridge National Lab. They are trying to purify zirconium from zircaloy cladding. They are using chlorination process, and they are missing data. So as you will see in the call, we need data for speciation of different radionuclides with chloride. This research also done by Emory Collins. So contact John Vienna or Emory Collins. They need these data to go on with this process. Like I said, we will have two presentations following this presentation by Dr. Stephen Kong. As a summary, so the fuel cycle research and development, material recovery and waveform emphasize on collaboration between academia, national lab. When I used to teach, I used to tell to my students 3 pillars. Don't forget the industry. Sometimes it's good to have some input from them. Like I said, we are applied research, and they can give you some ideas, for example, for the fission products, the gaseous fission products. What makes a good proposal? I was in your place not a long time ago, and I got an NEUP awarded. How did I get that? First thing, it's your pre-proposal. That's the most important. The title, your collaborators. Don't write, and I'm talking to the university, do not write a proposal alone. Outreach the national lab. We are going to fund people that have a link with the campaign. Science is beautiful. It's plenty, but we need to stay focused. Remember, we want to have a sustainable fuel cycle. So we are trying to have all these, I will say, proposals that could fit an environment in a university. Not everybody has access to radionuclides, to active materials. That's the reason it's important for you to team up with the national lab. It's important also for your students. Your students, this is our succession plan. And it's very important for them to be involved with the national lab to see a path forward in this career. With that, I'm looking forward to read all your pre-proposal and your proposal, and I wish you all the best. Thank you.
Over the next few minutes, we'll be taking questions for Patricia. So please submit those questions if you have them. Is there any change in the budget allocation for this year?
No, there's not so many changes, and I'm very sorry. I wish we could have more money to fund all these proposals. We are very limited. We're certainly going to fund again an IRP, which limits our funding for the NEUP call. I will tell you more or less what happened this year, and it will probably be the same next year. Approximately 3 proposals per call will be funded. I should not say per call. 3 proposals for material recovery, waste form, 2, 3 for the electrochemistry. It's more or less like this.
When you say that there will be a call for advanced waste forms relating to glass, ceramic waste forms, will this be part of the NEUP program in 2015?
Yes, it is. Yes, it is. Yes. Even though this program was transferred to the useful disposition campaign, now it's back in our campaign. We do not have the same amount of money, but it's still there. It's very important.
Is there any interest in nanomaterials research and development?
Yes, of course. Be creative. Be, get out of the box. But you talk to the national labs. Don't do that on yourself. Don't do that on your own. Talk to the national lab. Team up with them. Ask them. But of course, yes, always be creative, because it's, when you discover something, it's because it was out of the box. Suddenly you come, you have an idea. Yes.
Are you considering metallic waste forms?
That's a good question. Yes, we do, but not in this call. But yes, we do. In the campaign we have.
With only being able to put 20% of our budget towards national laboratories, how many national laboratory collaborators would you think would be appropriate?
No idea. I will say target 1. Target 1, because national labs are very expensive, or target somebody like me when I was in the national lab, where you're happy to advise and you don't take money. So target these people, and then you can have several national labs. And remember, most of the time the national labs, they will not take a lot of money because they know they are so expensive. The national lab will be there to open a door to your students to come in the summer and do some experiments.
Could you please tell me which national laboratory does work on capture of iodine, krypton, and tritium?
Yes. Essentially, it's Oak Ridge National Lab, Sandia National Lab. So Oak Ridge, it's Emory Collins, for example, Bill Delcul. In Sandia National Lab, you have to talk to Tina Nenov.
Are there any other calls for advanced waste forms in NEUP or in other areas?
No, this is what I just gave today.
Will new materials for the capture of off-gas be needed for
Yes.
FY15?
Yes, we work with how they call that, the organic framework. It's material organic framework. Yes, we work on that. we have aerogels, but if you think to something new, yes, please put this idea in it, because we haven't found the perfect extraction, capturing techniques for iodine. So that's the reason there's a call.
Is there any specific waste form that DOE is especially interested in?
Well, not at this point. You know, we are very open. Like I said, we do not have a repository. So repository, it's 2048 down the road. The waste form is also linked to the geology of your repository, as you can understand. So either we're going to choose glass or an advanced ceramic glass, or a waste form that will be adapted for a metallic fuel. We are very open right now. Hopefully in a couple of years we're going to strengthen our R&D and focus. But right now we're guiding also by a useful disposition, and it's a generic repository. So any ideas you may have are welcome.
We have a question coming in about FY14 awards.
Yes.
Those are not yet announced,
Okay.
and they will be announced in the near future. The other thing we would like to remind you of is if there is some type of research that is not covered in one of these areas, there is a final area called MS Meet 1 that is intended to capture all technologies that may not be supported or be focused on in the program supporting section